doing hypothesis testing? Very basic thing. Can anyone tell me? And please switch on your video. If I don't think you have bandwidth issue that much, so you can switch on your video.
Sir, I have bandwidth issues, so it will be better for me not to switch on.
Okay, but I don't think everyone has bandwidth issue. I don't believe that. So, Satvik, can you tell me when do you do hypothesis testing?
Sir, like, say we have a sample from a particular distribution and we want to test something about its parameters.
You start with the sample, okay, and then you want to test
Something about the underlying distribution of the sample.
Okay, fine. Shishro, can you tell me anything? How do you can tell me how do you frame a hypothesis? Probably there are two hypotheses, right? One is null hypothesis, another is alternative hypothesis. Am I right?
Yes, sir.
So, Shishro, can you tell me how do you frame this hypothesis? Or when do you frame this hypothesis? You can explain with the help of an example, not really a formal definition kind of thing.
So suppose we know the mean of a sample, we know the mean of a distribution, and we know the mean of a sample. So like let the mean of the distribution be mu naught, and that will simply mu one. So our sample, so our hypothesis, like null hypothesis, can be mu one not equal to mu naught, and the alternative hypothesis can be the equality condition. Then
yes, once you said that suppose you know the value of a population mean, like say mu naught, let's say 6, okay,
yeah.
And your H naught null hypothesis you can take as mu not equals to 6, and alternative hypothesis as mu equals to 6. Is that what you said?
Yes.
So what is the rationale behind that?
We were trying to see if the sample mean falls within if the sample falls within a population.
Like, sample mean falls within a population. What does that mean?
No. The sample we have taken correlates to the population mean we know, or that we have observed.
Do you really understand what you are saying?
Not that
about whether I understand it or not.
I am not able to frame it properly.
So take your time and frame it and tell me what's the right hurry. We are all sitting in our own room. Probably most of us in the house or in the hostel. We are not in hurry. So take your time. Okay, Valaisha, can you tell me how do you frame a hypothesis? How do you select a hypothesis? You can switch on your video and answer.
Actually, I'm with my mobile phone.
You can explain with the help of an example also, no problem. Anyway, you just explain it to me. How I will frame or decide on a hypothesis, H naught or H1 or whatever. Yes, Valaisha.
Sir, suppose we have some unknown parameters like the mean of a random variable or the variance of a random variable. Then we assume that, for example, mean is equal to 6 or like that. And then we see how our sample strongly suggests that mean is equal to 6 by hypothesis testing.
So what is your H naught and what is your H1?
So that depends. Like suppose H naught is equal to 6.
It does not depend. I suppose you are a statistician. I don't know statistics. So I give you full liberty to do this testing of hypothesis for me. So now, if you tell me that, well, I can take this or I can take that, so then if I think, so this is very completely vague. I don't know statistics. Say. So you decide on what would be your H naught and H1 or whatever. How do you test? So you tell
Uh,
me.
so the best would be like H naught is mu is equal to 6 and H1 would be mu not equal to 6.
You said that, okay, then best, you said that the best would be mu equals to 6 and mu not equals to 6.
Yes.
What do you mean by the best? Means, what is the
Sorry, sir.
significance of the word as best associated with this entire statement?
Uh,
Right, like Shishto just mentioned. So what's the problem if you, why don't you say that H dot mu not equals to 6 and H1 mu equals to 6? This wouldn't be best.
I mean, we are testing for mu equal to 6, right?
No. You don't ask me. Why are you asking me? I don't know statistics. I give you a job and you are asking me to do the same thing. That's it's very difficult because I am not a good. I don't know play cricket. I am not a good batsman. So I selected Virat Kohli to present India. Then Virat Kohli said that, okay, can you tell me how to bat or how to play outside the off stump? Then we selected him to play for India, and he's asking me, who is not at all a batsman probably. So why are you asking me? Shanti Dotto, where are you? Please switch on your video. Can you answer this question? That how do you frame given what is hypothesis testing or how do you frame H dot anything?
If we have a model which we want
Is there any
to
problem
test,
with your video?
let me try. The camera sometimes does not respond.
Sometimes does not respond. So sometimes it also responds, right?
It takes time.
Okay. Tell me.
Huh. So suppose we have a model y equals to, let's say, alpha plus beta x. We want to figure out if x has any strong, like the y has any strong dependence on x. So we want to check if beta is equal to 0 or not. So in this case, our null hypothesis would be beta equals 0 and alternative hypothesis would be beta not equals to 0.
I, I don't know, but I think Varunda, when he just introduced hypothesis testing, how did he start? Can anyone remember the first class that Professor Basho, Anandranath Basho, the way he started hypothesis testing? Did he started like this model, let's have a model like that?
So he started with a tire problem where we have several instances of several instances of tires, and we want to test whether the tires run for 50,000 kilometers or not. So, like, we have a pre-existing belief, and we frame the null hypothesis with that belief. And he also explained that the alternative hypothesis always doesn't need to be unequals to the mean or something. It can be like something which we are wanting to show. So, like, for a customer, it may be that he's interested in whether the tires have the running like they run for more than 50,000 kilometers. So our alternative would be mu greater than 50,000. And like we are trying to find out whether the true value is equals to 50,000 or and if it is more than that, then it is fine. But if it is less, then we have an issue with the sample.
So when do you when so that's a very good answer actually. You should have told like this because we have a model, we have a mu variance, it may be mu or sigma square. What is this? This is not statistics at all. So statistics always, this hypothesis especially, or actually the whole of statistics comes from real experiment, real data. And everyone except Rishi, you never mention anything on data, anything on experiment, anything on physical, any physical experiment. So it has no meaning actually. And unless you understand the Sanskar Lalwani, who is this fellow? Sanskar Lalwani, can you switch on your video? Where are you?
Yes, sir. 1 minute, please.
Yeah. Please switch on your video. I can't see you.
Sir, can you see me?
Yeah. I can see you. Nice. Thank you. So you look really nice, beautiful, very smart and handsome. My question is: are you present in my last class? That is the first class with you.
Yes, sir.
Yes. Okay. So I think I mentioned very specifically that you must be, not that you should be. I said that you must be punctual in my class. So, what is the trouble that you are facing today in entering my class on time? Because
Uh,
you are entering exactly after 28 minutes of the scheduled time, I believe.
yes, sir.
Yeah, so what is the reason? Can you tell me what is the reason?
Sir, actually, my PC is not booting from morning, and I was trying to do that for last 25 minutes, sir.
What are you doing?
Sir, my laptop is not starting up. That I'm trying for last 25 minutes. I called someone to
Oh,
get that started, but I don't know what is happening. So I'm joining from phone right now.
so you
I
could have.
gave up.
Okay, so that's a good reason, reasonably good reason. So when are you? Are you? Where are you? You are in your home or you are in the hostel?
Sir, I'm in my home right now.
So when are you coming back to ISI?
Sir, in the weekend, I'm coming on 22nd of January, sir.
Where are you? Where are you right now?
Sorry, sir.
You are staying your home. You are staying in your home. Where is your home at this moment?
Sir, it's in Nagpur, Maharashtra.
So why are you coming on 22nd? You didn't get tickets, or what's the problem?
Sir, the flights were really costly before that.
But how do you join on 21st?
So that I'm a little confused about. I did mail Dean about it, and he said that recordings will be provided for that day.
No. That's not the issue. Dean, what else Dean can say? That is the best thing he can do. He can provide you the recording. If
Yes,
you say
sir.
that I will not join in the whole semester, he will definitely do something. Probably he will take some steps in that situation. Okay, can you tell me what is the meaning of null hypothesis? How do you frame a null hypothesis in the context of hypothesis testing?
Yes, sir. So,
You can instead of giving formal definition and presenting in a very formal way, you can explain it using maybe an example or whatever way you want. No problem.
yes, sir. Sir, under null hypothesis, we take basic assumption about the parameter. Um, so 1 second. Uh, Sir, we use some prior info about the parameter which we are trying to test and form null, which helps us test about some property about the. So, like we were introduced to hypothesis testing with the example of the life of a tire, in which we assumed the null to be mu greater than mu naught, where mu naught was the mean stated by the company.
Very good. So what is your H0 and what is your H1?
So, in that, the null hypothesis was mu equals to mu naught, sorry, mu greater than mu naught, and H1 was mu less than mu naught, where mu naught was the average life stated by the company.
Right. Right. So now you understand what Sanskar is saying, and also Rishi mentioned that hypothesis testing always should be always is related to a practical problem. Okay. Not that X follows some distribution, it has parameters, I would like to test this. Why I am going to test this? So it comes from a physical experience like this tire. So so the company is claiming that the strength of the tire or the tire is strength is such that it will run at least 50,000. Okay. Now suppose you want to buy that tire. So what is your idea? You first see that whether you really want a tire to run for at least 50,000. So that means if it runs 50,000, you will be satisfied. If your understanding is that no, I want a tire that should run 60,000, then what kind of testing you will do? Suppose you are the company side, I want to buy a tire, and my perception is that I want a tire which should run at least around 60,000 miles. Okay. Then can you frame this as a testing of hypothesis?
So, is that question also for me?
Well, not really for you, but for all of you. So anyone can answer. Otherwise, I have to call by name and ask. So anyone can answer. You understand the question? That suppose you are the company, you are claiming that your tire will run for 50,000 miles at least. I am the customer. I want to buy a tire which will run for 60,000, at least 60,000 miles. Can you frame this as a testing from my side? Can you frame this as a testing problem?
Sir, H1 less than 60,000 and H not equal to 60,000.
H1 equals to 60,000, H1 less than 60,000. Okay. Shamprit, can you tell me anything? I did not say whether the answer is correct or wrong or more or less correct or it's okay. I did not say comment on anything. So you answer independently.
Sir, we can make H naught to be mu greater than equal to 60,000 and H1 to be mu less than 60,000.
Okay, good answer. Srija Bhakat, where are you? Switch on your video and can you answer this question? I want to know your answer. Srija
Yes. Sir, it is at least 60,000. Sir, can you repeat the question once?
you tell me whatever you have heard, then I will add on that.
Okay, sir.
So you tell me whatever you have heard about this situation, then I will tell you.
Okay, sir. H naught is
No.
Mu-
What you have heard about? What is the problem that I give?
at least 60,000.
No, please repeat.
Sir, I heard at least 60,000 miles.
Yeah, I want to buy a tire which should
Yes,
run for at least 60,000 miles. 60,000 miles, I will be happy. The company
yes,
claims
sir.
that it
It
is
is H
runs 50,000. So, what is your? How do you frame this as an hypothesis testing?
Yes, sir. H naught is mu greater than equal to 60,000, and H1 is mu less than 60,000.
Sir,
Yes, somebody is saying.
can I try?
Manoj, yes, yes, please go ahead.
Yeah, so I would like to like put the null hypothesis is something that I want to reject. So I would put h naught is equal to mu less than or equal to 50,000, 60,000, and the alternative hypothesis is uh, mu greater than 60,000, greater than or equal to 60,000.
Yeah, fine. Now I think I got all possible combinations of H0 and H1 with 60,000, less than 60,000 and greater than 60,000, right? With all these four answers, probably that covers everything. Uh, just give a pause and think for a few minutes. You are going to a tire shop, right? You have a car. You want to buy the tire. Okay. You want that this tire should run at least 60,000 miles. Is that okay? Do you understand? Now, when you go to the shop, the company, a particular tire company, it says that we don't have such a tire, we cannot guarantee, but we can guarantee that our tire will last for 50,000 miles. Right. Do you understand? So the tire company says that our tire gives you life of 50,000 miles. I want to buy a tire 60,000 miles. I don't know, is there any customer in the world who really wants to buy that tire from that company? It is not, the company is saying that I am not meeting your standard. Why are you buying that? Why are you even do the testing or all sorts of nonsense to come up with fancy results? Why do you want to buy? I don't understand. Do you get my point? You have, say, 30 rupees in your pocket. You went to Bonugli Junction and want to buy a say, chicken roll. You see that the chicken roll price is 40 rupees. Then at most you can say, can you give it to me 30 rupees? They said, no, I can give you maybe 35 rupees. You don't have that money. So what kind of testing you will do to come to a decision whether you buy it or not? You don't have the luxury. You don't have the money. So this is not at all a testing problem. Do you understand what I said? Because your demand is 60,000. Company is providing you, company is not even guaranteeing 60,000. It is giving you 50,000. Right? So why do you buy at all? Why do you at all negotiate? You were supposed to leave that shop immediately. And you should search for any other company which will give you a tire that will guarantee your life of around 60,000. So there is no testing scenario in this situation. Is this clear or is it still confusing? Yeah, so it is not that whenever I said that testing, you should think whether this is at all a testing problem, whether you can really frame it as a testing problem or as a statistical problem. Now, if I want to buy a tire of, as the mentioned that for 50,000 miles, company is claiming that 50,000 miles. Now, you have some doubt that okay, now I will check whether the company's claim is really valid. Then the question of testing comes. Even if the company says that your demand is 50,000, now company says that for 50,000, we are guaranteeing for 60,000. Even then you might be doubtful and you can check. You want to check. But of course you are a little relaxed when it says 60,000, I'm sure that I'm going to buy, but please let's have a check. That you can check. But if you want 60,000 and the company is saying 50,000, why do you even bother about it? You talk to that fellow at all. You cannot. Is this clear? Try to understand. This is a testing. So first, you should understand the basic problem. Now, let's talk about that 50,000 scenario. I want to buy a tire that will last for 50,000 miles. Company's claim is 50,000 miles. Now, fine. So A be what? Mu equals to 50,000. Average strength of the tire. Now, what you are going to check? Are you going to check whether it will run more, or whether you will check whether it will run less? Because if it runs more, that is good, that is better. So there is no need to check that. You should ensure that it should run at least 50,000. So your alternate hypothesis would be that the claim made by the company is false. That means mu is less than 50,000. Is this clear? Any confusion, any question? Anyone has any question? Please tell me. Is it clear to all of you?
Sir, repeat the company 60,000 and I want 50,000 part.
I want 50,000. Company is claiming 60,000. So I feel much relaxed, comfortable that I think this would be a very good tire. Right. But even then, if you have slightest doubt, not really the doubt, right? Like you definitely want to check when company claims 50,000, also want 50,000. It's not like that. Company is giving you more mileage, so you are more or less satisfied before even buying, looking at the claim. But even then, if you want to check, you can. But in most, with high probability that the company's claim will be validated because your demand is less. Then checking has at least some meaning. But the other thing, your demand is 60,000, company is not even meeting your demand, it's way behind. Then there is no question of talking about anything purchasing the tire from that company. So forget about any testing or any statistical problem. Stop your communication with that company and call another company. Is it clear now?
Yes, sir.
Now, Atik, you started your answer like we have a sample, and another one of you also mentioned that we have a sample mean, we have a population mean. I think but till now we have framed H0 and H1, right? Is there any mention of any sample?
No, sir.
No, sir. No, sir.
Yeah, we mentioned the data, but
we never mentioned the data till now. In this context,
we have not mentioned the data yet. As in shaping the H0.
Data comes much later. First, your objective, what you want to do. Right. Now, when you are deciding what to do, your demand 60,000, company is giving 50,000, you are not going to proceed. Decision is taken. But now, your demand 50,000, company is also giving you 50,000, then you want to check whether the company's claim is valid. So, you have framed your hypothesis. Up to the framing of hypothesis, what are the things that you have done? What are the information? You don't have data, but you have the physical experiment, physical problem. You have your objective in your mind, and you have some information about the population kind of parameter, or on an average, what is the mileage, how much it can run. That is, company is saying 50,000. The company is saying 50,000. That doesn't mean that it might run 20,000 or 30,000. That's really weird because the company will not survive. So it is around 50,000, you can say. It might be little less or little more, that doesn't matter, but it is around 50,000. So you have an information that the tire of this kind will run approximately around 50,000. So this is a partial information. So when this partial information, some information is given, and you want to validate or you want to check that information, then you should go testing. When there is some information is given about the population parameter as per your jargon, or in this case, average mileage by this tire, average strength of the tire in terms of miles, we have some idea. Now we want to check. That means we know that if whatever data we collect, if we collect the data, it is almost impossible that the data will all lie between, say, 0 to 1,000. It is almost impossible. Right? So that is the question. So here testing means we have partial information given. Sometimes we have no information, but no information also carries some kind of information. I'll come to that. Now, when you are going to frame the hypothesis, so company's claim is 50,000, so you want to test this claim. So your H0 would be average mileage would be 50,000. Fine. Now you have to design very carefully your alternate hypothesis. What is your alternate hypothesis? Do you want to check whether it runs more than that? If it runs more than that, you will be a gainer. You will be more happy. So I don't want to check that. What I want to check, that I'm not going to lose anything. That means I would like to check whether it is really 50,000 or it is less than that. So my H1 alternative hypothesis would be mu less than 50,000. Is that clear? So this is very important. Now again you observe that till at this point we have never mentioned about any sample, any observation, anything. Right? Only thing, very subtly, we have assumed that there exists a random variable. We assume that a variable is, let's say, X, which gives the strength of the tire in terms of miles. So now what we are going to do? We have to draw a random. Now again, there is another issue. You can never, especially in this example, even if you have enough money or all the money in the world, you cannot check all the tires produced by company. Because when you check, if you check all the tires of this company and you check whether someone runs 51,000, some runs 47, some runs 67, some runs 81, but the tire is actually got burnt out. The life of the tire is gone. So it is a destructive procedure. So you cannot do, even if you have enough money, you cannot sample or you cannot actually collect information on the entire population. So in this case, this is also a nice example that the utility of sample. So you select randomly a number of tires and let them run. Okay. This is the way you are collecting data. Now the data or sample comes at a much later stage. Using this sample information, you are going to test. Right? Now I am giving you another information, or rather, okay, let's not give you this information. Can you? So what we have H0, we have H1. Up to that point, we don't have any data. In order to test this H0 and H1, we are generating the data. We are doing the actual real life experiment and gathered the data. Suppose we select, say, 20 cars, 20 tires, let's say, 20 towers, let them run, and we collect data. Someone may be 51,049 miles, some might be 55,621 miles, something like that, some 20 such observations. Okay. Now, can you tell me, anyone tell me how do you do this test? So I have H0 and H1, right? H0 is average strength is 50,000. H1 is average strength is less than 50,000. Right? In order to do this testing, this problem, I collect observations from randomly selected data. There are say 20 such tires, and I let them run, let burn out, and I denote the time, life. One value may be 51,269 miles, another may be 62,142 miles, another might be 48,602 miles, like that. Like that, you have 20 observations. Now, using this observation, how do you test? Now, this, you remember, this is a very general thing anyone can do. You don't need a statistician to think that I need to have some information to test. Of course, collect some random sample or collect information that, well, can you tell me this? So you meet another person, can you tell me you have purchased a tire, so how much it runs? So he give you. That way also you can find some information. So that way you have 20 such randomly selected observations from 20 such randomly selected types. Now, how do you proceed to do the test that mu equals to 50,000 against mu less than 50,000? How do you proceed to do the test? Yeah, Prisha Reddy, can you tell me, Prisha Reddy? Prisha Reddy, are you there?
Yes, sir.
Yeah, switch on your video and answer my question. Try to answer my question.
Sir, I'm sorry, but I'm not exactly at my home. I can't switch on the video right now.
Where are you?
Sir, there's this function I had to come to.
You are in a function during the class. Oh,
I am so sorry, sir.
no, that's okay. So answer my question. Okay. This is the problem with online class. So did you listen to what I asked?
Yes, sir, but I'm not sure of the answer.
You don't need to be sure. Try to answer. You may not be able to give correct answer. Doesn't really matter. Try to answer. Ritanjan Raichaudhuri, where are you? Ritanjan
Yes,
Raichaudhuri.
sir. Yes, sir. Yes, sir.
Yes, sir. Can you please answer this question?
Yes, sir. If we assume the population to be normally distributed with some variance sigma square, then we can test for the equality of for the mean to be equals to 50,000 as x bar minus mu by sigma by root n, where mu is 50,000 and x bar is the sample mean, and sigma is the is standard deviation of the normally distributed population.
Why? So why suddenly this weird kind of mathematical expression you are using, x bar minus, what did you say, x bar minus?
Mu by sigma by root n.
Mu by sigma by root n is very difficult expression for me to remember.
Yes, sir.
Why suddenly, how do you get this? Why suddenly you have taken this expression?
Sir, because the distribution of this quantity is known, which involves mu. So
I can give you thousands of such examples of distribution of within code this quantity involves mu. Any function involving x1, x2, x20 involves mu. Distribution of any function involving x1, x2, x20 involves mu. Why suddenly you are taking such weird looking function?
this is the standard quantity for the
standard. Who has said the standard? If you say standard, somebody has said the standard with some reasoning.
It follows standard 0 and normal distribution. So
it doesn't really matter nowadays. So standard 0, what's special about standard 0 1? If I give you a normal distribution with mean 5 and variance 13.5, what's the problem? You can calculate anything you want.
yes, sir.
So how do you get this funny thing?
From the CLT.
CLT. You assume normality and now you are saying CLT. What is CLT? I don't know. Where are you? Where are you staying?
In my house.
And where is your house?
Chitla.
Chitla. If you have you ever come to Dhakuria region, Goria, Dhakuria?
Yes.
When there is a Dhakuria beach, so if you come from the Gol Park and if you come towards Jadavpur, on the Dhakuria bridge, on the left side there is a hall, big building. It's called I think Abun Mahal or something. Initially, it was known as Children's Little Theatre, which is also CLT. So, what is CLT? I don't know CLT. I know CLT means Children's Little Theatre. Can anyone answer this question? How to test this? Pranay, where are you?
Yes, sir. I'm at home.
Yeah, Jimmy, can you answer this?
Yes, sir. Um,
Good,
so
try.
practically, we don't know the variance of this test. So we'll assume we'll estimate a variance. Say
You
is
are testing about mu and you are starting with variance. I don't understand.
is uh,
You're testing mu equals to 50,000 against mu h1, h dot mu equals to 50,000 against h1, mu less than 50,000. And your testing problem starts with variance. Why not skewness or why not kurtosis?
mm, mm,
তোমার তো অবস্থা বেশ বাজে গো, terrible situation. Don't have the basic idea of statistics after 3 semesters. But I don't understand. The teachers you got, Vaushubidi and Aranda, they are probably one of the best teachers in ISI. So I can't believe, I don't really understand what happened to you. That only explanation is probably the effect of online class. Am I right? Because probably everyone, so all the exams were on online mode, right?
no, sir. The first semester was offline and
Okay.
next two are online.
So how much score did you get in first semester statistical methods 1? What is your score?
Mm, Sir, actually, I cannot remember right now, but it was around 76 or something like that.
What is your score in statistical methods 2 and 3? Must be more than 90.
No, sir, no, sir.
No?
In statistics method 3, it was around 80 and 2, I
But
cannot
anyway,
remember right now.
anyway, let's see. Rishi De Chaudhary, where are you?
So I am
Rishi,
currently
where
at
are you?
hostel.
Yeah, can you answer this question? You can switch on your video.
I am using my phone, like in the hostel Wi-Fi. I
So
cannot
where are
join
you in
from
the
laptop.
hostel?
Yeah, sir.
Hostel, you can't switch on your laptop or hostel Wi-Fi is weak.
No, no, sir. The hostel Wi-Fi, the Google Meet on my laptop doesn't work. Like it is restricted or something.
How is that possible?
Zoom works. So Zoom works, but
I
Google
don't have
Meet.
that technical expertise that they will block your Google Meet.
Yes, sir. It even blocks Discord servers and all those things.
I don't believe it. I don't believe it. I use Google Meet from any corner of my site. It was never blocked.
It
Anyway,
always shows me.
okay, it's really okay. Can you tell me the answer? What is the answer that I asked? The question that I asked. How do you do this test?
Sir, we find a test set statistic which involves the parameter, but the distribution doesn't involve the parameter, and like we can use that uh, test statistic to uh,
But
find
I
out
don't
the.
understand. Firstly, I don't know what is the meaning of test statistic. Secondly, I don't understand why do you require that the distribution of the so-called test statistic does not involve the parameter. I don't understand all these things. Nothing.
So
Okay, if
test
I want to
statistic
test
is
this by say x1 follows what? Normal distribution with mean under h naught 50,000 and variance sigma squared. Right. So what's the problem in that? Using x1, can I use x1 for this testing?
yes, sir.
So you will use x1. You are a great statistician. You are going to be a great statistician because you are in ISI. Britanjol, another great statistician, will do the testing with that funny thing, x bar minus, what is that, mu by sigma, sigma by n. What is that?
Sigma by root n.
Sigma by root n. Oh my god. Then someone will come up with sigma by n to the power 2/3. Oh my goodness. So two statisticians from the same institute will come up with two different statistics with two different conclusions, and being a non-statistician, I will be completely at a loss. So what is the problem?
Sir, his results maybe he's using the entire sample. He's using more information, and that is asymptotically more like better test because of the central limit theorem.
Rishi, you are in the hostel, right?
Yes, sir.
Can you do one small thing for me? You just go
What's
out of eyesight, cross the street, okay? You cross the street and go. There is fine food shops. There are nice, fantastic food shops, sweet shop and chop. You can get all sorts of things. So go to any shop and tell them that it follows asymptotically something. Will they understand anything? Or rather, you do one thing. Just in front of ISI main building, ISI main campus, 203 BT Road. Just in front, you cross the road. There is a tire shop. You go there and you tell that, well, I have calculated this average and it follows asymptotically normal. I don't know what they are going to do. Will they understand anything on that?
definitely no.
Then, so I told you that I don't know much statistics, so you should explain it in very common layman's language. That's expected. So, anyone can answer? Ishan?
So could you please repeat? I got disconnected. My Wi-Fi went away, so I joined with my mobile data. So I don't know the question.
Where are you? In your home or in any
At
function?
home.
In your
At
home?
home. Yes. So the Wi-Fi went away, so I tried to call my
Uh,
father, but so I
so
joined with
my
my mobile
question
data
is
just now.
H naught mu equals to mu naught against mu great less than mu naught. Mu naught is 50,000. H naught mu equals to 50,000 against H1 mu less than 50,000. So my question is, how do you, and you have a sample, say x1, x2, x20, 20 observations on the life of a tire, 20 such randomly selected tires. Now my question is, how do you test?
So I choose a test statistic, and I know the distribution of the test statistic under the null, and
I don't
I
understand what is test statistic under the null distribution. It's
choose some
what?
function of x1 xn, and
You choose a function of x1, x2, xn.
yes,
Okay.
and I know that x1 x2 xn follow some parametric distribution, and I assume that its value is the same as that specified by the null, and I according to that I can find the distribution of the function, and I then I know a range in which if the actual value from the observed value of the function lies, then for example I can choose a 95% interval, and if it lies in that region, then I will accept the
Is
null,
again
otherwise I will reject the null.
95% interval suddenly comes up. What is 95%? Regarding 95%, I know that you should get 95% marks. 95% interval means what?
If the probability that that it lies in that interval is 95%.
Suddenly, why probability comes into the picture? Where? Shatik, can you answer this?
Sir,
Asked you. No, Shatik. Okay, Oitijya Shaha, where are you?
Sir, I'm in the hostel.
Okay, good. Can you answer? You are also joining from your mobile.
No, sir, from laptop.
So you are in a hostel. You can join from using Google Meet. Another fellow did not join. What is happening? Equally random. Okay, so we can do one testing. Whether you can join Google Meet from hostel or not. Okay. So anyway, we think you can switch on your video and you try to answer the question that how do you proceed to do this test.
Sir, which test? Can you please repeat?
The one that we are discussing for a long time today, for the last.
If the difference between the sample mean and mu is large, then we reject the null hypothesis.
Very good. But why you are taking sample mean suddenly? That's the first time I got a at least good answer. So, but just tell me why suddenly you are considering the difference between sample mean and mu or 50,000?
Sir, sample mean is a good estimator of the mean.
Yes, very good answer. Very good answer. So, you see, try to understand what we just said just now. She never mentioned any bombastic jargon which that owner of that sweet shop or the owner of the tire shop will not understand. If you go to the tire shop and tell that, well, I have collected data, I have 20 observations. So I checked 20 tires from your company, and the average, on an average, it is around 50,000. Then that fellow will understand. But whatever you have said is completely way out of their head. It's not possible for anyone to understand. Now, she said that difference between sample mean and 50,000. Now, why sample mean? What did you say with it, June, just now? Why sample mean?
Sample mean is a good estimator of the
A sample mean is a good estimator of the population mean. Now, why are you suddenly talking about good estimator of population mean? The way you are thinking, you have the answer. I'm just rephrasing this in a different way. You know the answer. Try to tell me.
So if the null is true, then the difference between sample mean and
No. My question is why sample mean? You are saying sample mean is a good estimator of population mean. Now suddenly, why are you going for a good estimator? Okay, first I think, so what is estimation? Estimation means we don't have any idea about anything, let's say parameter, and we want to see what would be the possible value, what would be the tentative value and approximate value of the parameter. Now mu is what? Mu is the actual life of a tire, actual life, which I don't know. Company claims that it is 50,000. That is the claim given by company. But that is not the actual mean, you remember. So actual mean mu is unknown still. We have now a sample. Now I want to see whether the company is correct. We have a sample. Now we know that since we don't know the population mean and we have only a sample observations, so what naturally any non-statistician, any layman should do? He or she will work on the sample mean. Sample mean is naturally a good statistic, is a measure which is kind of representing population mean, because I don't know the population mean. Only thing I can work with sample mean. Right? That is very natural way to think. Forget about it's an estimator, forget about it is a good estimator, forget about everything. That is the first starting point. You are trying to investigate something with respect to what is called population mean, whose value is not known. You have sample. So the only thing you can do, let's see whether the sample mean, whether I can use sample mean. That is the reason, intuitively and from the common sense, the reason for using sample mean. X bar. In our notation, it is X bar. And later, or previously, we have seen that statistical properties, if you want to comment like bypassing other comments that sample mean is a good estimator of population mean. It has some statistical properties, I know, but right now I don't care. Only thing I know that I am happy with, since I am doing it, I would like to check population mean, I would like to work with sample mean, fine, no problem. So what I expect, now remember, now there is a very statistical concept. Remember, I have taken the sample randomly. This is very important. I have selected the sample randomly. Without, what is the meaning of randomly? Without attaching preference to any unit. There is a huge number of hundreds or 200 tires are there. I just blindfolded, I touch something randomly, I have chosen. Right? So this is a good representation of the population mean. So I expect that the sample mean should be a good representative of population mean. Is that clear? Now, what is the meaning of good representation? That mean we can expect that sample mean value of the sample mean should be close to population mean. Now remember, all that we can expect because we don't know the population mean. Why we can expect? Because from statistical properties we know sample mean is a good estimator of population mean. Now the good estimator comes. When I say that we expect that X bar is close to the population mean, why? Because it is a good estimator. Now comes the statistical property at a very last stage, probably, or last but last stage, after a long time it came. Any statistical concept came after a long time, except the randomness, which is the most important thing and which is often most ignored. Now, what I am going to check, I mentioned that H naught company claims 50,000. So I expect sample mean should be around 50,000, right? So I will take the difference between X bar and 50,000. Or if X bar is too large compared to 50,000, I will reject. I am wrong. I should not check whether it is too large because H1 is less than 50,000. So I will check if X bar is very small compared to 50,000. The sample mean, average mean lifetime of this randomly chosen 20 tires is much less than 50,000. So I will reject.
Yes.
Okay. Now there is one small issue that when I say that X bar is much smaller than 50,000, now this concept of whether it is small or large or the difference X bar minus mu, whether this difference is large or small, that should depend on the scale, right? If you think 100 is a big number, then with respect to the life of tire, 100 is nothing. 100 miles plus minus 100 miles is pretty nothing, right? But if you consider some other examples, 100 is huge. Probably everyone will be accommodated within that 100 length. So this span means the scatteredness of the data. Here comes the dispersion concept. Now this how the data are dispersed or the scale of the data, that will give you the idea whether it is. So you have to compare this whether X bar minus is small or large with respect to the scale or with respect to the dispersion. That is the reason we divide this thing by its standard deviation. Now why that root n comes? Because root n means the you have to divide this X bar minus 50,000, you have to divide this by its standard deviation. The standard deviation of X bar minus mu naught is actually sigma by root n. That is the reason root n comes, and that is the reason denominator. I never said, you also never said that you can consider sigma by root n into X bar minus mu. Why we are dividing this thing by sigma by root n? The reason is that we are making it scale free. We are making the scale as unit. Or this portion will be unit. So you can compare anything. This quantity is what you call your test statistic. It's a big name. So now you can compare this X bar minus mu naught or 50,000 by sigma by root n. If it is really small, you reject it. Is that clear? Now now again, if it is small, again, how small it will be? If you say 0, that is great. But if it is say 30 or if it is say 1, Will it be small? If it is 10, will it be small? If the difference x minus mu by sigma by root L is say 0.2, is it small? Suppose it is 2.9, is it small? So how to determine that? Do you get my point? So I just give you for to think. This thing leads to the two major concepts, two major quantities that are very frequently used in testing. That is, they are called what?
Level of the test.
Please speak loudly, I think so.
Level of the test.
Not really initially level of the test, but you are almost there. It's called type 1 error and type 2 error. Type 1 error and type 2 error. Okay. Okay. So, okay. Devabrata, where are you?
Sir, I'm here.
Yeah, Devabrata, can you tell me what is type 1 error and what is type 1 error? You switch on your video and answer. কি সাত্বিক বা
Sir,
কতবার অবধি পড়েছো? হাই তুলছো, ঘুরতে গেছো?
Sir, I cannot start my video now because the device I'm
Okay.
on does not have a webcam.
Okay, no problem. You answer my question. What is type 1?
Sir, type 1 error is, sir, it's the probability of rejecting the null when it's actually true.
No, type 1 error, what you said is probability of type 1 error. I asked type 1 error.
Sir, it's when we reject the null hypothesis when it's actually true.
It's when means it is some instances. What is type 1 error? When we reject H naught means what? I don't understand. Actually, the event or the phenomenon that you are rejecting H naught when H naught is true. Rejection of H naught when H naught is true. This event, this phenomenon, that is known as type 1 error. Okay. But my question is, when you said that rejection of H naught when H naught is true, but if you know H naught is true, then why are you rejecting H naught? I don't understand that. Can anyone tell me, suppose in this testing problem, I told you, well, I know that H naught is true. I know 100%. I'm guaranteeing you H naught is true. Then what you will do? You know that H naught is true. Then what will you do? Let's go to the basic again. You know H naught. You know that H naught is true. Then what will you do? Can you tell me? Or how do you do the testing?
We never reject the null hypothesis.
So no need of test.
Very good. There is no need of doing any testing. You're absolutely right. Like the concept, like the question that I claim 60,000 and a company gives me 50,000, there is no need to do the test. I will never buy from that company. You're absolutely right. Very good answer. So there is no need to do the test. I know it is 50,000. It is truth. Then why am I going to do the test? Is that clear? So be very careful that it is not that every time you have to do the test. When there is some kind of uncertainty, when you have that doubt, you suspect that it might not be, then only you can do the testing. Okay. So this type 1 error means rejection of H naught when H naught is true. But if we know H naught, then why are we going to reject H naught? So doesn't it look like there is a contradiction kind of thing? Because just now Satvik mentioned correctly told that if we know H naught true, then we will not do testing, right? But now we are defining type 1 error as rejection of H naught when H naught is true. Then is there any contradiction between these statements?
So it may happen that the sample that we get, uh, like it gives me some information that the mm, thing that I calculate for say the sample mean, the difference from the sample mean by the scaling factor. That
Can you
thing,
give an
it,
example? It will be nice if you think of in terms of an example.
uh, sir, it may happen that in that tire shop, I chose randomly, but my luck was bad and I got only the bad tires. And uh, so, and like,
Right, right, absolutely right, absolutely right. So let's move on to a different, easier example. Suppose I toss a coin. It's a coin tossing experiment. I want to test whether the coin is unbiased. Right. I don't know. So I assume that the coin is unbiased, but I want to sure. An alternative is say H1 P not equals to R, that the coin is biased. Fine. Now remember, I don't know that the coin is really unbiased. Okay. Now suppose the coin is unbiased. Actually, I don't know. Let's say God knows. If God exists, assuming that God exists, God only knows that the coin is unbiased. But I don't know. Right? And you cannot probably, I don't know what about you, but I cannot reach God. So naturally, we don't have any communication. So what I do, coin is unbiased actually, but I'm testing. So I toss a coin, I got a head, I toss it again. Now coin tossing, each toss is independent of the other. So observation of the outcome of the second toss has nothing to do with the first toss. So I got in the second toss, I get tail. Third toss, I get again head. Fourth toss has nothing to do with any all other three tosses. I again get head. So out of 20 tosses, I got 19 heads and only one tail. Right. Immediately, any person will immediately claim that the coin is biased because it is not possible. You will think. But if you look at each toss is independent of the others. So it is not impossible to get 19 heads and one tail. It is not impossible. You can get. However, the probability of getting such thing is very small, but it has a positive probability. It is not zero. So if you see that 19 heads, you immediately reject H0. But God will smile that yes, this fellow has taken a wrong decision. You will never know. You will never know. But the God will smile, this fellow has taken a wrong decision. It's known only to God now. So what we can do, so this thing can happen. So the objective of explaining this in this way is that this thing might happen. It is not impossible to happen. So what we can do, but we don't know. Even so, if I observe 19 heads, we don't know. We can think that, well, it is highly probable that it is coming from a biased coin. It might also come from an unbiased coin, maybe with a very small probability. But even if it comes from an unbiased coin, then the probability of observing 19 heads is extremely small. I agree, but it's a positive probability. So what we will do, this thing is an error. Although unknowingly I am committing this error. I don't know. Unknowingly, honestly, I am committing this error. But I don't know that this is an error. That's why what we do, we will calculate. So now remember, type 1 error is rejecting H0 when H0, this is an event. There is no mathematical or quantity associated with this. Everything is in a random setup. So we calculate, and you see, while discussing, this probability comes very naturally. So we calculate probability of rejection of H0 when H0 is true. This thing can happen. So this is probability of type 1 error. So what we will now want, is that we should not commit this error too frequently. That means we should say that I will perform the experiment in such a way that I will not commit this kind of error. That is, probability of my committing this type 1 error would be very small. You understand? Just follow exactly the same argument for a biased coin and accept H0. So probability of accepting H0 when H0 is false. Only God will be able to know. You will never be able to know. So you can calculate somehow, or you try to calculate. If you can calculate, rather I should say, if you can calculate probability of type 2 error, I should also try to design my experiment in such a way that it should reduce the type 2 error probability as much as possible. Is this clear to all of you? So now I have probability of two types of error, type 1 error, probability of type 2 error. Now my best option is that if I can reduce errors, that would be the best possible thing. Unfortunately, the sample size is fixed. Okay, we cannot minimize these two simultaneously. That is the reason what we can do, we can fix probability of type 1 error at a very low level. Let's say 0.00001, 0.05, whatever. That is chosen by you, depending on the seriousness of the type 1 error. So now you have only type 2 error, probability of type 2 error. So our only job is the minimized probability of type 2 error subject to the restriction that probability of type 1 error is less than or equals to some alpha. Alpha is called level of significance. So this is the way we can proceed to do test. Is this clear? Any question? Any question? No question at all. No question means either I am a very bad teacher or I am a very good teacher. Now, if I ask that which one I am, then obviously the response will be biased. Okay. Anyway, any questions? Satvik, you want to ask any question?
Yes, sir. Could you explain the last bit where you said we were fixing the probability of type 1 error?
So suppose the probability of the type 1 error you think is very serious error. You don't expect to commit it very frequently. So I don't want to afford to take any risk. What I will do, I will develop my test procedure so that it will ensure that probability of type 1 error will be very, very small. Let's say let's say 0.00001 or maybe 10 to the power minus 10. No problem. It's your choice. If you think probability of type 1 error is not really that serious, it will not harm anybody's life, you can consider 0.05, 0.01 like that. So it depends on the choice. Because remember, once you fix probability of type 1 error and when you try to minimize probability of type 2 error, your probability of type 2 error will be minimized, but the minimum value you don't have the control on that. It depends on the performance, the procedure. You can get the minimum value to be 0.00001, or you can get even that minimum probability of type 2 error would be 0.3. There is a minimum value that you can get. So you cannot take that risk at that point. So you judge which error is serious. So you consider, you fix the probability of committing that more serious error at a very low level. If you see that probability of type 2 error is more serious than probability of than type 1 error, then you should fix probability of type 2 error at a very low level for which you are satisfied. Then you minimize probability of type 1 error. It's like that. So the error which is more serious, we should not take any risk on that. Because if we let it be minimized freely subject to the other restriction, it might not attain the desired limit, or desired low limit, low high. Okay. Any question? Okay, so I believe you try to come a little early, maybe 21st. We will meet face to face. Okay, in room 520, I believe, right? Room number 520. I think so. Please check. And remember, please be there on time.
So will the class start at the same time, 10:25?
As now it will be on the same time, but initially the classes used to start at 10:15. It doesn't really matter. You will get a notice. If you receive no notice, that means it will start at 10:25.
So, sir, 22nd, right?
21st. 21st is Monday. Oh, my class will be on 22nd, right? My class will be on 22nd. And who asked that the time of class is 10:25? Who asked this question just now?
So it was me.
Oh, okay, that's fine. So Yeah, the class will start at 10:25. Okay, if there is no other notice. If there is a notice, you will be able to know. But if there is no notice, the class will start at what time?
10:25, sir.
10:25 a.m.
Yeah.
And I believe all of you know that there are actually infinitely many numbers between 25 and 26. Right? So timing is 10:25 a.m. Okay, see you on 22nd.
Sir,
Yes, sir.
sir, are you a class teacher?
Mukherjee. Yes, yes, yes. Yes.
Okay, sir.
Yes. Okay, bye.